Okay, so here we have the grasshopper definition for my wind sensor, which is designed to fit onto the facade of the building, so as the wind picks up, the panels close to protect the facade of the building from dusty and chamal winds. So here's the definition. This is the fixed part of the definition, which is the module frame. If we just preview this, as you can see, this module frame is fairly simple, and this holds the 6 panels which rotate as the wind increases. So here's the part of the definition for the panels. As you can see, we've copied this 6 times with rotations, and if we unpreview this, you'll be able to see how these panels fit. So this part of the definition was just controlled by one number slider from 0 to 90 degrees. So this was how it will be normally, and as the wind picks up, the sensor will sense this and the panels will close to protect the facade of the building.
So here is the setup for the project. I have the physical model, which is connected to this Arduino Uno board, which is the open source hardware program, which is also connected to this breadboard and the laptop, and this controls the physical model, as I've already shown. The physical model has one micro servo, which is attached to this gear and these gears here, which control the 6 panels which are designed to open and close according to the wind speed to protect the inner of the 2 skins on the Dubai ambient tower in high-speed dusty winds. So I've already shown the Grasshopper model being controlled within Grasshopper, but here I've added the physical model, which is designed to be a modular panel. The model is being connected via this Firefly definition and this Arduino code and fermiter, which is called a sketch. So now I'll control the physical model via Firefly from this definition, which is controlled by this single number slider. And as we can see, when this number slider is changed from 90 to 180 degrees, the physical model and the Grasshopper model rotate simultaneously to simulate the opening and closing in lower and high wind speeds. So I've shown the digital and physical model being controlled by Grasshopper and Firefly. Now I'll control both models via real-time data and a pressure sensor, which when calibrated to a very sensitive level can pick up changes in pressure, which obviously vary with wind speed. So I've added this piezo sensor, pressure sensor, and a 1 megaohm resistor to the breadboard, and this sensor has been connected to Firefly via a read component, which ultimately sends signals to the servo. It's calibrated so when the wind speeds reach 8 meters per second or more, the panels will close. So if I blow on the sensor and the wind speed is above 8 meters per second, the panels will close and they will open again when the wind speed drops. So now I'll blow on the sensor to simulate wind speed. So if the sensor is positioned the correct distance from the building facade, the panels will close before the wind hits them, therefore protecting the inner building from the dusty wind. And as well as serving a functional use, this facade, which interacts with the wind, would also provide quite an aesthetical view, as the tower is very tall and it will be visible from miles around.
Okay, so the final part of the project is to be able to use the physical model or each panel as a weather station. So each module on the building facade will react, collect and log data individually. So for the early site analysis stage or later stages, data can be collected for specific areas of the site or building to determine, for example, where the wind speed is lowest on site, which would determine where is the best place to put a doorway, for example. I'll now alter the wind speed by blowing on the sensor. I've set the panels up so they will close at any speed greater than 8 meters per second, as this is around the speed where dust will be picked up by the wind. I've set a graph to visualize the wind speed, as well as displaying it numerically, and the data can be logged into a spreadsheet and archived for future reference. So I'll now blow onto the sensor to replicate wind speed. As you can see, when I blow on the sensor, the wind speed increases and the panels close, which is what we want.